So imagine you're tiling your bathroom, and this time you want to deal with part tiles. So imagine we've got 2.5 tiles. So here's your standard 2. So we square 2 and we get 4. We got 2 there, we turn them into a square, we get 4 tiles. Easy. What would happen if we had 2.5 tiles? I think I'll just use a slightly different color here for the half bit. So here's my half tile. Try and draw this carefully, like so. Okay, what do we get? Well, we get 1, 2, 3, 4 halves, so that's 2 extra tiles we need to do that. And what's this little guy in here? Well, it's a half of a half, which is a quarter. So the answer here is that if we take 2.5 and we square it, we can see we get 1, 2, 3, 4 plus 4 times a half plus a quarter. Okay, now we haven't really covered fractions yet, but fairly common sense that 4 times a half equals 2. So this is 4 plus 2 plus a quarter, which equals 6 1/4, or said differently, 6.25. So 2.5 squared is 6.25. This is cool. This means that we can square numbers that aren't whole. All right, and you can see from the image I've drawn you at the top left how that intuitively makes sense. Let's try it again, just for something a little bit different. Let's try 3.5 squared and see what we get as an exercise together, all right? Just to prove that squaring these non-integer numbers makes sense. So here's your standard 3 squared. We take the number 3, 1, 2, 3, we make it into a square. What do we end up with? 9. Okay, now let's come along and say, well, actually, I want to turn 3.5 into a square. What do we have? Same deal. Basically the same deal. Okay, we have all these little half squares down here, and then in the top we've got this little quarter square. So now it's roughly the same thing. We're just simply saying that 3.5 squared, I'll do it below so we've got the space, equals 9 plus, and then we've got all these little rectangular bits apart from the quarter. So we've got 1, 2, 3, 4, 5, 6 halves. I could do this in green, couldn't I? 6 times a half plus a quarter. Okay, and then we can just collapse that down to 9 plus 3 plus a quarter, which equals 12.25. So I think that's pretty cool. It gives you a basic intuitive understanding for how you square a number that isn't a whole number in the first place. Now, where does this apply in games? Well, it's going to apply in a lot of instances where you need to be thinking about areas and amounts of texture, amounts of pixels that you need to cover certain areas, etc. So the next question you might ask is, how would you do this in code? Well, we would do something like this. For the top example, it would be code that looks something like this, POW, or whatever your API is in your particular program, of 2.5, and then we're raising that to the power of 2. All right, and if we ask the compute computer, does this equal 6.25, then this would come back as true, i.e. yes, it does equal 6.25. For the bottom example, we're asking the question, what happens if we take 3.5, raise it to the power of 2, does that equal 12.25? And the answer is true. Okay, now remember, in computer terms, equals equals is what we need to do when we're trying to do a comparison, and that equals itself, a single equals, is effectively an assignment operator. All right, that's pretty cool. So this allows us to start thinking about how we deal with non-whole number powers, which is going to be super useful because basically everything you're going to be dealing with on a computer is going to be a non-whole number. So I hope that's helpful, and I'll see you in the next one.